Boy, this one sure looks different than what we used to have.
Hi, what are you so deep in thought about?
Who said that?
I did.
Who are you?
I'm the narrator of this film. Now, what is it you were wondering about?
Well, just a few things, actually. I just saw a ProTech film on the new 1980 Citation, and I've got some questions about the engine, transaxle, and just a few other things on it.
Okay, maybe I can answer your questions, especially about the engine and transaxle. That's what this ProTech film is about.
What? You mean we're in a ProTech film?
Sure, in fact, you're the star. If you're ready, we can start.
Okay, let's go.
Better move out of the way. Here it comes. ProTech presents 1980 Citation Powertrains. In the two earlier ProTech films on the 1980 Citation, you were introduced to the new Citation and its components, and you were shown on-car service procedures. In this film, we'll look more closely at the engines and two transaxles that are available on the Citation. Now, how about if I just go ahead and start talking, and maybe your questions will get answered as I go along. Then, when I'm finished, if you still have any questions, I'll answer them.
Fine, go ahead.
As you were told in the two earlier ProTech Citation films, there are two engines available, an L4 and a V6. There are also two transaxles, a 4-speed manual and a 3-speed automatic. By the way, notice that I'm not using the term transmissions, but rather transaxles.
Now that's something I've got a question on because I've never seen the inside of a transaxle. So I don't have any idea on how it works as compared to a transmission on a car with a rear wheel drive.
Okay, we'll see how they work in a little while. But for now, to end some of your confusion, think of the difference in this way. On a car with rear-end drive, since the transmission is up at the front of the car, it has to turn a prop shaft in order to turn the rear wheels. However, on a car with front-wheel drive, the transmission, the drive axles, and the drive wheels are all located in the same area at the front of the car. Therefore, the transmission can turn the wheels directly through the axles. What you have now is a transmission combined with the axles, thereby the term transaxle. I've oversimplified the explanation, but I hope you get the point. Before we really get into the transaxle, I'd like to cover the power plant that makes all this work, namely the engine. We'll begin with the engine that is standard, or base equipment on the Citation, the 2.5-liter L4. If you've serviced 1978 Monzas, you should be familiar with this engine. And if you attended the new product school for 1979, or have seen the ProTech program covering the 1979 new Chevrolet products, then you're familiar with the changes on this engine for 1979, such as the new cross-flow head, distributor relocation, and the redesigned intake manifold with equal-length runners. So, basically, the 2.5-liter being used on the Citation is the same engine that is on the 79 Monza, with a few differences, of course. The major difference between Citation and Monza 2.5-liter engines is that the one in the Citation is transversely mounted. This in itself requires some modifications. One of these modifications is the water pump, shown here in blue, which is now mounted on the front side of the block. Since the engine is transversely mounted, the pump faces the right side of the car. Something else different is the coolant flow. On an engine that is conventionally mounted, as shown here, the coolant leaves the radiator and enters the front of the engine at the water pump and flows toward the rear of the engine. However, in order for the coolant to return to the radiator, its path has to turn around 180 degrees so that it can flow back to the front of the engine. It then leaves the engine at the thermostat and returns to the radiator. This means that the water pump and thermostat are usually located near each other at the front of the engine. This type of turnaround flow isn't necessary in the Citation. Since the radiator is adjacent to the side of the engine instead of the front of it, the coolant can enter the engine at the water pump, flow through the engine and then exit at the thermostat on the opposite end of the engine, instead of doing a 180 to flow back again.
But the way the cooling system functions is still the same, isn't it?
That's right. The only thing changed is the coolant flow and the use of an electric thermostatically controlled fan.
While you're talking about the engine being transversely mounted, just how is it mounted?
Okay, in the Protect film that introduced the Citation, you saw the new split cradle that is being used. The engine mounting system for the Citation consists of 3 basic rubber mount and bracket assemblies between the powertrain and the cradle. There is one mount located in the left front corner of the cradle, another located in the left rear corner of the cradle, and a third one in the center position along the right side rail of the cradle. In addition, a torque reaction type of engine restraint, or strut, is mounted from the engine to the upper radiator support. This strut is pretty important since it is part of the engine load-carrying system. The one shown here is for an engine with a manual transaxle. A slightly different design strut is used for an automatic transaxle. However, both types of engine struts use rubber bushings and are held in position by brackets at both ends. And basically, that's the 2.5 liter. As I said, if you're familiar with the one used for the '79 Monza, this won't be that new to you. I am not going to cover the cooling system, the electrical system, or any other on-car systems for this engine because they're already covered in the Protect film that introduces the Citation. Instead, let's move on to the engine that is all new for this car. Here it is, the 2.8 liter V6. This is an all-new engine that was designed specifically for the Citation. As we go through this engine and see just what's in it, you're going to find that quite a bit of it is just like other engines that you've serviced. We'll concentrate on those areas that are quite different. Like the 2.5 liter L4, this V6 is also transversely mounted. What would normally be the left side of the engine faces the front of the car toward the radiator. What is normally the right side of the engine faces the cowl. This places what is normally considered the front of the engine, where the accessory drives are located, next to the right side rail. Here's something that's different from other V6s that are presently used in GM cars. The cylinders are banked at 60 degrees rather than 90. Not only does this result in more room under the hood, but it also provides an even firing engine that is smoother running and more vibration-free. Notice also how the valves, shown in blue, are offset inboard and are vertical to allow a more central spark plug position, thereby minimizing the width of the head. The spark plug is shown here in red. While we're in this area, a couple of other new things. Instead of being pressed in, the rocker arm studs, shown in green, are threaded into the cylinder head. This is a similar design to the present setup on L82 Corvette engines and 454 CID truck engines. You might also find one or more lifters, shown here in purple, that are oversize on this engine. Usually, during production, if there is a problem while installing a lifter, they'll compensate by putting in a bushing so that the fit is correct. However, on this engine, instead of using a bushing, they'll rebore and install an oversize lifter. Incidentally, these are long travel lifters, so when adjusting them, an extra half turn more than you usually do is required.
How much of this engine is metric?
For practical purposes, the whole engine is metric. And by the way, even though some of the parts in the 2.8 liter might look the same as parts from another V6, they're not interchangeable. In fact, hardly anything on this engine is interchangeable with any other existing GM engine.
Before I forget, I want to ask you about the cooling system. Does this engine also have the one-way flow-through like the 2.5 liter?
Right. The coolant enters the engine at the water pump, flows through and leaves at the thermostat on the opposite end of the engine. Also, notice the different front cover design. It not only serves as a front cover, but also acts as the rear portion of the water pump. Both the front engine cover and the water pump housing, as well as the inlet manifold and the oil pump body, are made of aluminum, Here's a few service notes about the intake manifold. To remove the intake manifold, you must first remove the rocker arm covers. This is because each rocker arm cover extends over the inboard side of the top of the intake manifold. RTV is used as a seal here. Even though the distributor doesn't go through the intake manifold, it still has to be pulled in order to remove the manifold. This is because part of the distributor housing covers one of the studs, shown in blue, that retains the intake manifold. Before you have enough clearance to remove the nut from that stud, you'll have to get the distributor out of the way. One more point about the intake manifold. The push rods go through the intake manifold gaskets. Any time that you have an intake manifold off and are going to install new gaskets, you'll find that the replacement gaskets are solid along the edges. This keeps the edges from becoming torn or tattered during shipment. However, this also prevents you from being able to fit the gaskets behind the push rods. No, you're not going to have to pull the valve train apart just to install the gaskets. Just use a razor blade or sharp knife and cut the gaskets in the areas shown here. Then, just fold that part of the gasket around the push rod as you install it. Notice also that each gasket is marked right or left. It's important that you pay attention to the markings and install the correct one on each side. The reason for this is as shown here. There is an opening in the water jacket of the right cylinder head to allow exhaust gas to flow into the intake manifold. The right gasket also has this opening. The left gasket doesn't. If you install the left gasket on the right head, the exhaust gas flow is blocked, resulting in uneven heat distribution throughout the intake manifold. This, in turn, affects proper emission control operation. There is also more extensive use of form-in-place gasket materials on this engine. You're familiar with RTV, and as shown here, it's being used in a number of places where a sheet metal part is joined to a machined surface. Included are areas such as the rocker arm covers and the oil pan front and side rails. There is also another sealer that is being used more extensively this year, an anaerobic sealer. As you can see, its composition is pasty. This sealer is used where machined surfaces are attached to machined surfaces, such as the water pump to the engine front cover and the engine front cover to the block. One other place it's used that's not shown here is under the rear main cap. These are areas where the mating surfaces are too rigid to use a composition like RTV. Because of its pasty composition, anaerobic sealer can be spread very evenly on a machined surface. More important, though, it will not dry as long as there is air present and no pressure is applied to it. You can apply this sealer to a part, lay the part down for an extended period of time, and when you pick the part up again, the composition of the sealer will still be the same. However, as soon as the pressure of mating parts is applied and air is removed from the presence of the sealer, it cures and becomes plastic in composition, providing the required strength for correct sealing. Okay, a few more things about the 2.8 liter. No doubt you're used to the number 1 cylinder being on the left bank on GM engines. For this engine, it's on the right or rear bank. As shown here, the firing order for the 2.8 is 1, 2, 3, 4, 5, 6. The fuel pump is actuated by a push rod to a camshaft eccentric. The pump is similar to the one used on Chevette. Also, to get at the fuel pump, you'll have to remove 2 shields, shown here in green and blue. These protect the fuel pump from exhaust heat and road splash. The thrust bearing on a Chevrolet crankshaft is normally the rear bearing. However, on this engine, it's the number 3 bearing. By the way, the rear main seal on the 2.8 is rope instead of neoprene. It's very similar to the type of rope seal being used for the rear main on the 3.8 liter. Shown on the left is a conventional automatic transmission for rear-wheel drive. On the right is the new 125 automatic Transaxle. Look different? Except for the final drive, they function just about the same. Since the transmission portion of the Transaxle functions the same as a conventional automatic transmission, we're not going to cover the Transaxle power flow. Instead, we'll see how power is transmitted from the end of the Transaxle gear train to the drive axles. One of the final gear train components that is a part of the power flow in this Transaxle is the final drive sun gear shaft. This hollow shaft has the left drive axle positioned inside of it, as shown here. In order for the drive axles to function, it is necessary to transmit power from the final drive sun gear shaft to them. This is done by a unit located at the output end of the gear train called the final drive assembly, which has replaced the pinion and ring gears that are on a rear-wheel drive vehicle. This final drive assembly is a planetary gear set consisting of a final drive internal gear, which is splined to the transaxle case, a final drive sun gear, which is splined to the final drive sun gear shaft, and the final drive planet pinions, which are located in the differential and final drive carrier assembly. This gear set operates as follows. Power through the final sun gear shaft drives the sun gear, shown in blue, which in turn drives the planet pinions, shown in green. Since the final drive internal gear, shown in red, is splined to the case and will not rotate, the differential and final drive carrier assembly will also then rotate, thereby turning the drive axles. The 125 has 3 forward and 1 reverse gear ratios. Just as in a conventional automotive transmission, the changing of the gear ratios is fully automatic in relation to vehicle speed and throttle position. There is one big difference about this transaxle as compared to other GM automatic transmissions. When reading the fluid level, the indication is the reverse of what you're used to reading for other automatic transmissions. For the 125, the oil level on the dipstick is higher when cold. The reason for this is that due to the low profile of the 125, a reservoir area other than the oil pan is required to operate the unit with both hot and cold fluid levels. This reservoir, which is located in the lower section of the valve body cover, is controlled by a thermostatic element. The element operates by opening and closing according to the temperature of the fluid that is trapped in the reservoir. As the temperature of the fluid in the reservoir increases, the volume of the fluid increases. Consequently, there is less fluid in the oil pan, and a lower reading will be indicated on the dipstick. As the temperature of the fluid in the reservoir decreases, the thermostatic element opens and allows the fluid to drain into the lower sump or oil pan, thereby showing a higher reading on the dipstick. Before we leave the automatic transaxle, there's one adjustment that I'd like to quickly show you. The transaxle detent control cable adjustment. First, depress and hold the metal lock tab. Then move the slider back through the fitting in a direction away from the throttle idler lever until the slider stops against the fitting. Release the metal lock tab. Rotate the throttle idler lever to full travel stop position in order to set the automatic cable adjuster on the cable to the correct setting. Release the idler lever, and that's all there is to it. Okay, I've been throwing a lot at you. Am I answering your questions?
Yeah, but there's one thing you haven't covered.
What's that?
The split cradle that was introduced in the earlier Protec film.
All right, let's discuss it. On the Citation, during an R&R of an engine and/or a transaxle, usually the engine is pulled from the top and the transaxle is removed from the bottom. To help speed clutch and transaxle service, this split cradle can be opened up and half of it swung out of the way. Stay with me now, and I'll go through the sequence of opening it up. First, disconnect the battery ground cable from the grounding bolt on the transaxle case and attach it to the upper radiator hose with wire or tape to get it out of the way. Make a mental note as to which bolt it should be connected to for reconnecting later. Install the engine holding fixture, tool J22825, so that one end is supported on the cowl tray near the passenger side wiper pivot and the other end is resting on the radiator support in the position shown. Attach the fixture hook to the engine lift ring and tighten the nut to raise the engine just enough to take pressure off the motor mounts. Make sure the steering column is locked and raise the car. Remove the two nuts that are attaching the stabilizer bar to the lower control arm on the driver's side. Remove the 4 bolts attaching the retaining plate that holds the stabilizer bar to the cradle on the driver's side. Loosen, but do not remove the 4 bolts on the bottom of the retaining plate that holds the stabilizer bar to the cradle on the passenger side. Pull the stabilizer bar down on the driver's side. Then remove the 2 lower nuts at the front transaxle mount at the cradle and remove the 2 nuts at the rear transaxle mount at the cradle. Remove the 2 rear center crossmember bolts. Then remove the 3 cradle attaching bolts at the front part of the cradle on the passenger side. To get at the nuts for these 3 bolts, pull back the splash shield next to the frame rail. Remove the left front wheel, and then remove the front and rear cradle-to-body bolts on the driver's side. Using special tool number J28468 and a slide hammer, position the tool as shown and remove the axle shaft from the transaxle assembly on the driver's side. Swing the driver's side of the cradle away from under the car. Wire or tie it securely in the open position. Don't neglect this last step. If it's not tied down, the cradle can swing back toward the center of the car while you're working there.
That does make a difference with that cradle out of there. It looks like the transmission...
Correction, transaxle.
Oh, yeah, excuse me. It looks like the transaxle is pretty accessible to work on. What about putting the cradle back together again?
Basically, it amounts to reversing the procedures we just covered. However, here are a few tips to make it easier. When you first swing the cradle back into position, install the 3 front cradle attaching bolts on the passenger side. Don't tighten the nuts on the bolts yet. All you want to do at this point is have the cradle in position. But also, don't forget to come back later in the procedure and tighten those nuts to specification. And by the way, make sure that the driver's side of the rear center crossmember is in front of the passenger side. It is possible to incorrectly position the driver's side behind the passenger side. Once the cradle is in position, install the front and rear cradle to body bolts on the driver's side of the cradle. After this, just reverse the rest of the procedure. Well, that's it. Any questions?
No, not on what you've covered. But since we're in this area, will you answer something about the front suspension?
How about if I hold off on that? I've already covered quite a bit in this film. We'll cover Citation suspension, steering, and brakes in the next ProTech film.
With me in it again?
Sure.
Okay.
In this film, we have discussed the applications of the 2.5-liter engine, the 2.8-liter engine, the manual transaxle, and the automatic transaxle in the 1980 Citation. We have also shown you the split cradle, which was designed to provide faster service on these engines and transaxles. However, with this being a new car with new components, there's a lot more information about them than time would permit us to present here. Refer to the Citation Service Manual for all the procedures you'll need to successfully service this car. And I'll be seeing you in the next ProTech film in this series on the 1980 Citation.